This is the explanation of the answer key to the Explore that's on page 156 and 157. Step 1 was to make the table for Carl and for Anna, and that would hold the answers to the range, the interquartile range, and the mean absolute deviation. So I did that right here. These answers weren't in here yet, I just made that table. Step 2 was to find the range of Carl's scores and the range of Anna's scores. So to do that, I had to find the largest score for Carl, which was 95, and the smallest score, which was 60. They were in order on page 156 at the table at the top. And the difference between 95 and 60 is 35, so I put that right there. And to find the range for Anna's scores, I found the small score, which was 73, and the largest score, which was 100. Found the difference, which is 27. So again, zooming in, the range for Carl is 35, and the range for Anna's scores is 27. So Carl's range is a little bit larger. The next step was to find the interquartile range. So to understand that, we need to understand where the 5-number summary came from. So I added a little explanation right here. The 5-number summary was given in the chart on page 156 for Carl as 60 as the minimum, 78 as Q1, 85 as the median, 90 as Q3, and 95 as the maximum. 78 is not one of Carl's scores. The reason that 78 is Q1 is because there are 9 test scores for Carl. 85 was the middle score, median, and it is one of his scores. But that leaves 4 scores to the left and 4 scores to the right. So we had 60, 75, 81, and 85 to the left, the smaller 4 to the left of that 85. So 78 is halfway between the 2 middle scores, the second and third scores, 75 and 81. So I add those together, divide them by 2 to find the mean of those 2 scores, 75 and 81. So that gives me Q1. I had to do the same thing for Q3. Carl's scores were 87 and 93. Those are the 2 middle scores of the second half. It's a little difficult to understand where that came from. It's not shown in the book. So to get 90, you have to average his score of 87 and his score of 93. It's kind of like the median of the second half of his numbers. But because there's 9 numbers, then we have to use just the 4 that are to the right. 86, 87, 93, and 95. So that's where we get a Q3 of 90. Now, after we do that, finding the interquartile range is as simple as subtracting 78 from 90, finding the difference, the distance from this 78 to this 90, and that's where I got that 12. I did the same thing for Anna, but because she had 10 scores, 10 test scores, then Q1 and Q3 were a lot easier to find because there are 5 smaller scores and 5 larger scores. So of the 5 smaller scores, Q1 is the middle score, 78. That was one of her test scores. And of the highest 5 scores, 96 was the middle score. But I put in an explanation of how you got median, even though it wasn't needed for the interquartile range. You take the 2 middle scores, 84 and 85, and average those to get halfway between. So her median is 84 and a half. So finishing up step 3, the interquartile range for Carl was 12 and the interquartile range for Anna was 18. So the middle section of Anna's scores were wider than Carl. Carl's were more, a little closer together. So then that leaves step 4 for finding what's called the mean absolute deviation. To find the mean absolute deviation, you have to have the mean, which is given to you on page 156 for Carl's 83, and subtract 83, which is the mean, from every one of his scores. So 60 minus 83, 75 minus 83, 81 minus 83, 85 minus 83. So the difference between 60 and 83 is negative 23. For the next one, negative 8, negative 2, 2, 2, 3, 4, 10, and 12. We want to find the absolute value of those numbers because we want to find the average of these. So the absolute value of negative 23 is positive 23. Remember, the absolute value is the distance a number is from 0, and the absolute value is always positive. So negative 8, the absolute value of negative 8 is 8, and the absolute value of negative 2 is 2. Once I have this list, this is how far any of the numbers are from the average. So the smallest number is the farthest away, and then once we get to the middle, we get closer to the average. And then once we get to larger numbers, we're farther away from the average. The final step is to find the mean of this column. So I added these numbers together, 23 plus 8 plus 2 plus 2 plus 2 plus 3 plus 4 plus 10 plus 12 is 66. Divided that by the 9 numbers that are there, and got 7 1/3. So the mean absolute deviation for Carl is 7 1/3. I went through the same process for Anna. Her mean was 87, a little higher than Carl's mean, and I found the difference between each of her scores and the mean. 73 minus 87, 76 minus 87, 78 minus 87. So notice these are all subtracting 87, finding the absolute value of that difference, and then finding the mean of that list of numbers. And her mean absolute deviation was 8.4. So I put that right there. So the final step was to make 2 sentences. Your sentences could definitely be different than what I have. But number 1, I said Carl's scores had a greater range compared to Anna's. So 35 is greater than 27. So it would seem his scores are more spread out. But Anna's scores had a greater interquartile range than Carl's of 18. So the middle section of Anna's were more spread out than Carl's. Their mean absolute deviations are pretty similar. What I noticed is if you only looked at, for example, the mean, you might think that Anna's scores were much higher, 83 compared to 87. Or if you looked at the range, you might think that Carl's scores were more spread out, much more spread out, with a higher range. But if you just throw out their lowest score, so let's say Carl doesn't have 60, Anna doesn't have 73, their scores are almost the same. And that shows up in the median. Their medians are almost the same. And the median does not get affected by much lower scores or much higher scores. So Anna's scores had a greater IQR than Carl's, which means that the middle section of her numbers were more spread out. So what this lesson is showing you is there's more ways to look at a set of numbers than just the range or the mean or median. There's more detailed ways to see what their scores are like.